Alright, today guys, what we're going to do is look at and try to understand how to factor sums and difference of cubes, which should not be confused with difference of squares. Cubes is something to the third power or multiples of 3, and squares are to the second power or multiples of 2. And so here we have a situation where we need to be able to factor things that look like these examples here. All these examples here are what we're going to be working on. So here's what we need. You guys need to memorize these formulas here. Now, they're pretty much the same formula. What you'll notice is if your problem starts out with a plus sign, this is representing the plus or the subtraction or the sum or the difference of two cubes. If you can write both of them in terms of something to the third power, is what this says right here, then all you do is substitute into these formulas. A squared minus AB, B squared. Notice that they're pretty much the same except for the signs. Okay? So if it's a minus or a difference, the first sign is a minus and the rest are a plus. If it's a sum of cubes, the first sign is a plus, the second sign is a minus, and then the last sign is a plus. So plus minus plus, minus plus plus. But it's the same thing. Let me show you how to work this, and you'll see that factoring sums and difference of cubes are very simple. Remember, the first rule of all factoring is to look for a greatest common factor. And I don't have one here. There's no greatest common factor other than 1. I noticed that this is a cube, which is a hint to me that I might have a sum and difference of cubes. And if I can rewrite 8 as something to the third power, which I can, how do you know that? Well, you take that number, 8, you do the cube root of 8. Now, just in case you didn't see how I did that, you would hit 3, then function this button here. That turns it into a cube root of 8. And whatever number you want to see, if it's a cube root, if you get a whole number, then you know it is. And so that's how I wrote 2 to the third power. All right. Now, this turns out to mean that A equals X and B equals 2. That's A and that's B based on my formula here. The first one to the third power and the second one to the third power. Hopefully you understand what I'm pointing at. Since this is a plus, I'm looking at the sum of cubes here. All right? So how does that work? I'm going to substitute everything into this. So that's X plus 2. That's A plus B. And then in parentheses, A squared, which is X squared, minus A times B, which is 2X, and plus B squared, which is 4. That's how that factors. This does not factor anymore. Your trinomial does not factor any further. All right? Now, let's look at example 2. I'm dealing with a difference of cubes here. In example 2, this is a difference. I have 2 terms, and I'm dealing with a difference of cubes. How do I know it's a difference of cubes? Well, at least it gives me the idea that there's a 3 as an exponent. And so I'm looking at this, and I don't know if 216 is a perfect cube or a perfect cube. So what I do is I grab my calculator, the cube root of, wrong button, the cube root of 216 equals 6. So that means 6 to the third power is 216. So again, the idea is for you to be able to write everything in terms of something to the third power. Okay? Once you do that, you realize very quickly that A in this problem is actually A and B is 6. So why is that important? I'm using the difference of cubes now, which is very similar to the sum, and I'm going to follow this pattern, A minus B and so on. So that is A minus 6 or A minus B times a squared, which is a squared, plus ab, which is multiplying those two. So 6 times a is 6a, plus b squared, which is not 12, but 36. That is your answer. You can see that the sum and difference of cubes is not that difficult. If there's an issue, it's going to be, how do I write things to the third power? Now, number 1 and number 2 are kind of the baby steps, and then we get into problems like number 3. Now, number 3, I have 2 terms, and I am looking to factor this difference of cubes, which I'm not sure it is, but again, having that 3 as an exponent gives me an idea. But in order to do that, everything has to be able to be written as something to the third power. So I get out my calculator again, and I say the third root, or the cube root of 64. And that gives me 4. So that works. So I can take 64x cubed and write it as 4x to the third power. See, now it's different. It's not just one number, one variable. It's 4x to the third power, because this right here equals 64x cubed. Check me out. 4 times 4 times 4, and x times x times x is that. So yes, it steps up a little bit. Sometimes it'll look like this, and others it'll look like this here. All right? Now, can I do 27 and write that as something to the third power? Well, let's see. Even if you already know it, I'm going to show it to you. The cube root of 27 is 3. So that means I can write this as 3 to the third power. And again, I'm able to write those as something to the third power, which again is what my hint says. So that means I'm going to use the difference of cubes formula, which is up here. The difference of cubes formula says A equals 4x and B equals 3. All right? It says to do A minus B. Then it says do A squared. Now, what is 4x squared? What is 4x? I'm going to zoom back in here. What is 4x squared? Is it 8x? Is it 8x squared? No, 4x squared is 16x squared. Then it says AB. The formula says do AB next. So, and that's a plus, by the way. What's 3 times 4x? That's 12x. Then it says plus b squared, which is 9. B squared is 9. All right? Find out A, find out B, and substitute into the formulas there. All right. Finally, number 4 here. I've said it several times. I haven't said it here lately, but the first rule of factoring is to look for a greatest common factor. I noticed that both of those were even, so I can at least divide out a 2, and I believe that's my greatest common factor. So you get 216 plus 125, oops, didn't mean to do that, m cubed, and then close it up. So that's a wicked looking m, but it's an m. Alright, so again, our friend, the greatest common factor, shows up again. It doesn't matter. I'm still going to do what I normally do with my greatest common factor once I factor it out. I bring it down on each step. It needs to belong in the answer. Now I'm just going to focus on these two here, and I'm going to try to write these in terms of something to the third power. I already did 216 earlier, and I remember that that's 6 to the third power, plus 125. If you don't know, you can get out your calculator, but I know that that's 5m cubed. 5 times 5 is 25. 25 times 5 is 125. And so I know that this is how you would write this in parentheses. And I'm going to put that times 2, not to forget that. So how does this work? I bring my 2 down, and the steps tell me, since it's a plus sign, it says, and you can look on your paper, you can actually pause this and do it yourself, but it says do A, which A equals 6 and B equals 5m. it says do A, which is 6, plus B, which is 5m. Then it says do A squared, which is 36, minus AB, which is 6 times 5m, which is 30m. Then it says do B squared, and that's a plus B squared, and B squared is 25m squared. That's your answer. Now, I suppose if you wanted to, this right here, and are the same thing, but it's not necessary for you to do that. It's definitely not necessary. Now, real quick, I just want to show you that this is right. I want to go back to number 1, this example here on number 1. Remember how we talked about how to multiply stuff out like this? Let's multiply to see if we get this problem, because I don't think some people believe that this works. So if I did x times x squared minus 2x plus 4, I would get x cubed minus 2x squared plus 4x. And then if I took 2 times that same thing, I would get 2x squared, and then I would get minus 4x, and then I would get plus 8. So I already lined everything up, and notice that what comes out is x cubed, cancel, plus 8. You see how that worked? It is a true statement. So again, guys, you don't have to ask, did I do this right? If I take the time to multiply it back out, I should get my original problem here as my answer, including the signs. All right, good luck.